We see wonderful things around us every day. Lights off, lights on. What happened? Not able to see anything? What carries information around us to our eyes and brain? Yes, you are right. It is light. When light falls on an object, the object reflects light. And when this light is received by our eyes, we are able to see things. There are a lot of wonderful phenomena associated with light, like twinkling of stars, formation of image, etc. In this chapter, we'll study the properties of light and also explore these phenomena. We generally see when an opaque object comes in the path of light, light casts a sharp shadow of the object. We can also see the path of light when light enters a dusty room through a window. From these observations, we can say that light travels in a straight line path. In this lesson, we'll study the phenomena of reflection of light, which uses the property that light travels in a straight line path. A highly polished surface, like a mirror, reflects most of the light falling on its surface. From our previous classes, we are familiar with the laws of reflection, but still, let us recap them once again. The angle of incidence is equal to the angle of reflection, and the incident ray, the normal at the point of incidence, and reflected ray all lie in the same plane. We are also familiar with the properties of the image formed by a plane mirror. The image formed is virtual, that is, the light rays don't actually meet at the point but only appear to meet. The image formed is erect, the size of the image is equal to the size of the object, the distance of the image from the mirror is equal to the distance of the object from the mirror. Also, the image is laterally inverted. Let us see what happens if we curve the reflecting surface of the plane mirror. Let us perform an activity. Take a large shining spoon and view your face in it. Now, move the spoon away from your face. Do you find any change in the image? Now, reverse the spoon and perform the same activity. Still, do you find a change? The curved surface of the spoon can be compared to the curved surface of a mirror, and the most commonly used curved mirrors are spherical mirrors. The reflecting surface of the spherical mirrors are a part of a sphere. Therefore, the mirrors whose reflecting surface are spherical are called spherical mirrors. Now, let us explore these mirrors in detail. The reflecting surface of the mirrors can be curved inwards or outwards. If the reflecting surface is curved inwards, that is, the reflecting surface points towards the center, it is called a concave mirror. If the reflecting surface of the mirror is curved outwards, that is, the reflecting surface points away from the center, it is called a convex mirror. In the activity we performed, we can see that the surface of the spoon bulged inwards can be approximated to a concave mirror, and the surface bulged outwards can be approximated as a convex mirror. Let's have a look at some of the basic terms related to spherical mirrors that will be used in future. The point at the center of the reflecting surface of a spherical mirror is called a pole. It lies on the surface of the mirror and is represented by P. The reflecting part of a mirror is a part of a sphere, and every sphere has a center point. This point is called the center of curvature and is represented by C. Note that the center of curvature is not the part of a mirror and lies away from the reflecting surface. The radius of the sphere of which the spherical mirror is a part is called the radius of curvature, and it is represented by R. Now, if I imagine a straight line passing from the center of curvature and the pole, the line I get is called the principal axis. The principal axis is the normal to the mirror at its pole. Now, once we are clear with these terms, let us perform an activity. Hold a concave mirror in your hand and point its reflecting surface towards the sun. Now, direct the reflected lights towards a sheet of paper. Now, move the paper back and forth until you receive a bright spot on the paper. Now, just hold the paper and the mirror in the same position for a few minutes. What do you observe? Initially, the paper starts to produce burning smoke, and if you keep it a little longer, it may even catch fire. What causes the paper to burn? The concave mirror converges the light from the sun, and the bright spot we see on the paper is basically the image of the sun. This point is the focus of the concave mirror, and the heat generated due to concentration of sunlight ignites the paper. Let us draw a ray diagram and get a better understanding of the outcome of this activity. A number of rays parallel to the principal axis fall on the concave mirror, and after reflection they meet or intersect at a point on the principal axis. This point where these rays meet or converge is called the principal focus, and it is represented by f. The distance between the pole and the focus of the mirror is called the focal length, and it is represented by small f. In the activity we performed, the distance between the pole and the point where we got the brightest spot is the focal length of that mirror we used. Now, in place of a concave mirror, if we take a convex mirror, the reflected rays appear to come from a point on the principal axis, and this point is the principal focus of a convex mirror. The diameter of the reflecting surface is called the aperture of a spherical mirror, and it is represented by Mn. In our entire discussion, we'll only work with mirrors whose apertures are smaller than the radius of curvature. For spherical mirrors with a small aperture, the radius of curvature is equal to twice the focal length, that is, r is equal to 2 times f. This implies that the focus lies exactly midway between the center of curvature and the pole. In the start of the lesson, I told you that light travels in straight lines, and it casts a shadow if an opaque object comes in between. But if the size of the opaque object is very small, light has a tendency to bend around it, and we call this effect diffraction. You'll study more about this effect in your higher classes. So let us quickly recap what we learned in this lesson. We revised the laws of reflection and the properties of images formed by plane mirrors. We introduced two types of spherical mirrors and also learned about various terms related to spherical mirrors.